Good morning, everyone. We are going to see the vector equation of a line in 3 dimensions. The general equation of a line is r equals a plus t d, where r is a vector from the origin to all the points of the line, so the origin 0, 0, 0 to all the points of the line. For example, if I take the point A 2, 3, 5 and point B minus 3, 1, 2, I want to find the equation of the line that connects these 2 points. The vector A could be the vector that connects the origin to A. So for example, the equation of the line would be x, y, z, r, which is all the points of the line. The vector A, of course, is this vector, whose coordinates are the same as point A, 2, 3, 5, plus t, any real number, and the vector D. The vector D is a vector parallel to the line. So for example, we could use the vector AB as the vector D. So the vector D could be the vector AB, which is OB minus OA, where OB, of course, is the same as point B because it starts at the origin. So the vector OB is minus 3, 1, 2, and the vector OA is 2, 3, 5. And subtracting gives minus 3, minus 2, minus 5, 1, minus 3, minus 2, and 2, minus 5, minus 3. This could be the vector D, minus 5, minus 2, minus 3. This is called the vector form of the line. From here we can obtain the parametric equation just by writing x equals 2 plus t times minus 5, so 2 minus 5t, y equals 3 minus 2t, and z equals 5 minus 3t. These are called the parametric equations of the line. From here we can solve for t equals x minus 2 over minus 5. From here t is equal to y minus 3 over minus 2, and from here t equals z minus 5 over minus 3. From here we can see that all of these are equal to t, therefore we can equal them. So x minus 2 over minus 5 equals y minus 3 over minus 2 equals z minus 5 over minus 3. And this is called the symmetric equation of the line. In reality, these are 3 equations. This equals that, this equals that, and this equals that. Each one of them is y equals mx plus b, or y equals nx plus nz plus d, etc. I mean, these are 3 equations of the form y equals mx plus b. There is no single equation like in 2D. In 3D, these are the 3 ways to describe the line. Pay attention that there are infinite ways to write the equation of the line in the vector form. The same line would be. Now here we need another point on the line. So getting a point on the line, just plug different values for t. For example, if I plug into t the value minus 1, here I get 2 plus 5, that is 7, 3 plus 2, that is 5, and 5 plus 3, that is 8. I'm sure that this point 7, 5, 8 is a point on this line. This vector is any multiple of this vector. So for example, if I multiply this by minus 2, I get 10, 4, 6. This is exactly the same line. We can do the same, obtain the parametric equations, but in general it's exactly the same. So there are infinite ways to write the same line in the vector form. Pay attention that when t is 1, for example, we get this is d and this is r. That's when t is 1. When t is 2, then the vector 2 times this is this vector, and therefore R becomes that. In this way, R reaches all the points of the line depending on the value of t.